So a lot of people are confused about this, so I think I'm going to explain it because I am no physicist, and I think there should be someone to explain it in layman's terms. If we're talking about missile guidance, it can be incredibly complex, of course, and that makes it rather difficult to actually understand what is going on. So really, for missile guidance, there are two types of systems. Either GOT systems, go onto target, or GOLIS systems, which are go onto location in space. Now, GOLIS is effectively there is a point in space. We want the missile to go there no matter what happens. This is often used for stuff like ICBMs. Whereas GOT is the one utilised far more nowadays. Cruise missiles may have a GOLIS system, but GOT is effectively there is a specific target, let's say a tank, which may move. But you want the missile to go to that particular target no matter where it moves to. You don't want it to just go to a location in space. Now within GOT systems, which is go on to target systems, there are really two types of guidance. The first is remote control. That means that the platform that launches it effectively takes control of the missile and guides it to the target. And then the latter is homing guidance. Now just to go over remote control guidance, it's not as common nowadays, but I'll just go over it quickly. Generally, the most common thing, and I won't go into the entirety of it, but the most common thing or system utilized is known as CLOS, which is Command Line of Sight. Now, effectively what that is if you have, let's say this is the launch vehicle and this is the target, and there is no particular way to do this, so I will just use my head. The launcher effectively launches whatever it is, and let's say the target moves. It effectively tries to put the missile equidistant between where it is and where the target is, and effectively that means that there is a likelihood that by the time it actually gets to the target, it will hit the target with a decent degree of success. It tries to put the missile in the linear equidistant point between itself and the target. And it really is that simple, and I think that's all I'm going to cover on that, because the majority of systems nowadays utilize homing guidance, because generally it's far better tactically, because it means that planes can do what they want, launchers can do what they want, and it means that there's effectively more mobility, and it's also just easier in regard to utilizing missiles, and often more accurate. So the first thing I'm going to talk about is radar homing. And this is a really, really simple way to remember it. We often hear terms like it's active, it's passive, it's a semi-active seeker. Now, these three categories are really, really simple, and I'm going to use the example of radar here to describe it. There is active homing. Now, active homing is effectively where there is a missile. This missile sees the target. It fires whatever it might be radar, it might be a laser. It fires this radar or laser or LiDAR, whatever it is, towards the target, and then receives a signal back, and then it utilizes that in order to go towards the target. It seeks this signal, effectively. And what this means is that there is a transmitter of radar, of laser output, as well as a receiver in the missile itself. It doesn't rely on the launch vehicle in order to illuminate the target. Now, for semi-active homing, this is different. Whereas before, we had, let's say this is the missile and this is the target. For active homing, we had beams coming off the missile, and here's the target, and coming back to the missile so that it can locate where it's going to go. But for semi-active homing, we see something different. We need a command vehicle to take some sort of a role. Now, semi-active homing, whether it be laser semi-active homing or radar semi-active homing, requires an external source to illuminate a target. And when we say illuminate, we mean fire some sort of a beam at it. That looks weird, but I'm going to leave it. So this may be radar. It might be a laser, and it will fire this radar or laser, whatever it is, at the target. This command vehicle, generally a launch vehicle, but it can be something else, potentially even satellite. And once it fires this, it illuminates the target, and there is a receiver within the missile itself that can read these signals and then can locate the target. Now, sometimes this can be best because you have often a more stable vehicle for the transmitting of these waves. You have the illumination of the target via an external vehicle which can keep its distance, as opposed to the missile, which might not necessarily be so accurate because it is moving in such an erratic, unsteady pattern, effectively, particularly if it's an active seeker. But again, these have been improved. So active, it's transmitting beams and it's receiving beams and it's going where it gets the beams back from. And then semi-active, something else is transmitting these beams, it is receiving these beams and it's going to where it's receiving these beams from. That's it. So it's effectively the same concept. It's going towards the source of these beams, whether that be lasers or whether that be certain radar signals. Now, if we talk about passive homing is a bit different. People associate it with being, I guess, similar, being in the same category, but it is something else. It's effectively where there isn't any readback. So if you remember, active homing is from the missile itself, forward and back, and then semi-active homing is from something else and back. Passive homing is there is just one signal coming from the target itself towards the missile, and the missile will go towards that target. So generally, this won't be a radar signature. It's probably most famous in the case of infrared homing, often really colloquially referred to as heat seeking. It will go towards a certain radiation given off, or contrast seeking, which is effectively where it utilizes a black and white TV camera and where there is the most differentiation, i.e. the colors changing the most in front of the missile. It will go there and lock on. It's going towards a certain signal that is from an external source, either the vehicle itself, in the case of infrared homing, or in regard to contrast seekers, that's literally the sun. So hopefully that is enough for today, but simply remember, there is remote control, there is homing, there is go on to target, there is go on to location and space. There is active homing, which is sending a signal from the missile forward to the target and back to the missile. There is semi-active homing, which is sending a beam, a signal from an external source, whether that be a launcher, generally it is the launch platform, to the target and back to the missile. Or there's passive homing, where it's going after something that either the target is emitting itself, whether that be heat or an infrared signature, or whether that be merely its movement and its change in perceptual color via a TV camera. So hopefully that explains it.